Good evening, all of you. And today I'm going to do something which is not too much relevant for JEE examination, but it is definitely an integral part of JEE syllabus. So today I'm going to prove IVT, which is intermediate value theorem. Some authors also call it principle of dichotomy. So let's start. And before I go further, first let's see what exactly the theorem talks about. So the theorem goes like this. Let f be a continuous function, writing with CS, defined on an interval I, which is closed interval a to b. Then for any real number k, which belongs to fa and fb, there must be at least one value of c belonging to the interval I such that fc equal to k. Now usually when we state this theorem for JEE preparation, it's quite intuitive because we try to justify it, if not prove it, by using graph. So let's say we have a interval a to b, both included, this closed interval, and now our function is defined in this interval. So let's set a, the output of the function is fa, and at b the output of the function is fb. So what basically this theorem tells is, for any real number k which lies between these intervals, so let's say if I take some real number k over here, corresponding to this number will have an input which comes from the window of a and b, right? So there exists some c in this window such that f of c equals k. Now that feels quite intuitive because the condition of continuity is too much injected in this following theorem. It does not mean the converse of theorem is true, okay? Because you can think of a function which satisfies this theorem, but it might be discontinuous. For example, one of the way of thinking function is, let's say y equal to x from 0 to 1, right? And f of 0 I'm giving 1 and f of 1 I'm keeping 0. So you can clearly see this function is discontinuous in the closed interval a to b, where a is 0 and b is 1, because endpoint discontinuity. But you give me any input, any value of k which belongs to the output 0 to 1, okay, you give me any number half corresponding to this, there is some input, right? Even you give me 1, so corresponding to 1 there is an input which is 0, right? So the function I have defined it as f of x equals x for x belonging to open interval 1 to 1. It is 1 at x equal to 0 and is at 0 at x equal to 1. Okay, so although this function satisfies the condition of IVT, it does not means, okay, like the function is continuous. So the converse of this statement is not true. This is usual confusion. The first I wanted to define it. You can give another function example also. For example, f of x equals sine 1 by x for x not equal to 0 and is 0 for x equal to 0. Now clearly you can see, you give any real number, sine 1 by x will behave something like this, right? In the vicinity of 0, because it will be oscillating. And moreover it is odd function, the more or less nature will be something like this. Just rough nature I am showing you. At f of 0 it's exact 0. So you give me any real number between, like -1 to 1, so it will be at many value. So corresponding to any values of k, y equals k or f of x equals k, we have an input. In fact, we have more than one input over here, but still the function is discontinuous, right? So this was a warning. The converse of a statement is not true. in general, right? Now let's come to the proof part. So for proving, we'll construct two adjacent sequence. So let's consider the following graph first. Let's call this point as A and that input is B. So I'm defining function in this interval A to B with the output as f of A and let's say f of B. Okay. Now suppose without any loss of generality, I take f of A is less than f of B. If it is other way around, so we can consider a new function g of x equals minus f of x, right? So that will automatically guarantee other way around, f of A will become greater than f of B. So I can start this without any loss of generality of the problem statement, right? अब देखो हम क्या करेंगे? Let's construct two adjacent sequence A and B with the following algorithm. So now I'm constructing two sequence of number A and sequence of another number B. Sequence means we'll try to see numbers A1, A2, A3, A4 in some fashion. Similarly, numbers B1, B2, B3, B4 and so on till infinity, till n. Okay. And we do it as follows. So given a number A and B, of course in the closed interval, we can always find its midpoint. So let's say A plus B by 2. Okay. Now corresponding to midpoint, definitely we'll have some output. Let's call A plus B by 2, I'm calling as M. M means midpoint. So corresponding to this, we'll have some output f of M. Now, what is the problem statement? We have to prove, like, if there exists some k between fb and fa, so each and every step is very strong statement. Okay, so listen to this carefully. Because usually it is proved by different methods. So I'm trying a new way of proving this, and I think this is more satisfactory. So corresponding to k, we have to prove, like, there exists some input over here. Okay, this is what you have to prove, for which the output will be k. Okay. Okay. So now if m is A plus B by 2, so we can have only two situations. Either f of m will beat k, or f of m will be beaten by k, or f of m will be equal to k. So I can take equality in any case. So we'll have only two of the following situations. Now what I'm defining is, suppose if this case comes, if f of m is more than equal to k, right, which is clearly in this diagram as of now, then I am defining a1 as the sequence a1 as a and b1 as m. Else, if it is fm is less than k, then I'll define a1 as m and b1 as b. So what I mean is follows. Let me review the diagram and again to give you a full feel. So we have functions from a to b, a, b. We have got a midpoint a plus b by 2. So in this situation, this is f of m and this point I'm calling as m, right? And let's say f of m is more than k. F of m is more than k. So here in this case, I'm defining a1 as a. So this point I'll call as a1 and m is known as, if m I call as b1. So in this chunk, somewhere we have an output k that actually we need to prove, right? So this is how our sequence of definition goes. I hope it is clear. Otherwise what we'll do is, again, if we have a and b, and now suppose k is more than the midpoint average, so we have again m is in corresponding to this f of m, where m is midpoint. So now I'll define a1 as m and b1 as b, right? So this point I'm calling now as a1 and b1 as b. This is the interval of a1 b1. So I hope it is clear. At b we have clearly the output for b. So now I know, like, k is between. Okay, so in any way what we are doing is, a is definitely less than equals a1, less than equals b1 and less than equal to b, and output wise k is lying between fb and fa, because this was already known. Now we'll repeat the process again and again. Okay? So if I'll repeat the process, so what we'll do, let's take suppose this diagram. तो यहाँ पे we have already seen under this condition we have a point A and we have got midpoint M, and now we want to analyze it in A and M where this is A1 and B1, right? In K is the value which is lesser than f of M. अब यहाँ से I reiterate this again. So again I take a midpoint of A1 and B1, right? And let's call again M. I still will have two cases. For example, at this site, suppose now this new updated M I am calling M. Still I am giving the same name, but I have, like, you can call M star or M1 or whatever. So now for this M, by according to our definition, our algorithm, how I will define our algorithm. So if the middle point of the intervals are again satisfies, क्योंकि यहाँ पे आप देखो, if f of m will be more than equal to k, then we'll make a2 as a1 and b2 as m, and if it is less than k, then a2 as m and b2 as m. तो since it's less than k, तो यहाँ पे what I'll define m को, मतलब this new midpoint को now I'll call it as let's say a2, and this new midpoint को I'm calling it a2 and b2. So let's call this b2 and a2, right? So a1 I am calling as this midpoint, we are calling as a2, and this one we are calling as b2, right? And we'll keep on repeating, because again I'll take a new midpoint corresponding to this. I'll go to the functions. Okay, again it will be either less than k or more than k. So we'll keep on repeating this process again and again. What I tell is, language of algebra, M is, again I am defining a1 plus b1 by 2. Okay, the middle point of interval, such that if m of a is greater than or equal to k, then I am defining a2 as a1 and b2 as m. Otherwise means if fm becomes less than k, then I'll define a2 as m और b2 as b1. तो बेसिकली यहाँ पे होने वाला जो चीज़ है वो कुछ इस टाइप का होगा. देखो फील के लिए ए और बी ये था, मिड पॉइंट यहाँ है. सपोज के इज ऑलरेडी फिक्स्ड, राइट? के इज नॉट चेंजिंग and I have to prove the existence of this point. So suppose if midpoint is here now, I'm taking just one of the example, a plus b by 2. So corresponding to this is greater, right? Now I'll take the updated midpoint of a and this new guy, and let's call, I use different color to say this is a new midpoint. Now at that midpoint I'll get the new output. Okay. So now I'm interested in again this interval, this new interval in which k lies. I'll repeat the process. I'll take again midpoint, and let's say now midpoint comes again here. So corresponding to this midpoint is more than k. So I'll again keep a new interval like this, यहाँ से यहाँ, right? Again we'll take the midpoint, and now suppose it becomes lesser than k, right? So now I'll take again this new interval. So we'll keep on playing this. So we'll reduce the size of interval no matter where you start it. तो यहाँ से आप clearly देख सकते हो कि what we have done in the second step is a is less than equal to a1, is less than equal to a2, is less than equal to b2, is less than equal to b1, is less than equal to b, and f of a2 is definitely less than equal to k, is less than equal to f of b2, and we'll repeat this so on. So now we therefore construct a sequence of segment growing smaller in size, okay, and such that in the interval a and b is a1 b1 is a subset of a and b. Similarly, this is a subset of blah 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 till a n comma b n, subset of, and so on and so forth. Right? Now we can clearly see a sequence n is an increasing sequence and bn is a decreasing sequence, the way I have constructed this, right? Furthermore, by the very construction you can see what is the gap between let's say if I tell a1 minus b1. So since a1 was a and b1 was b, okay, and the midpoint was a plus b by 2, सो आई हैव डिफाइंड दिस गैप एज द गैप बिटवीन a1 माइनस b1. तो ये गैप जो आया मेरे पास आ गया a प्लस b बाई टू माइनस a का गैप. सो दैट वाज a माइनस b बाई टू अमाउंट, or I can tell it is b minus a by 2. Similarly, what is a2 minus b2? So again this half of this gaps, that will become b minus a by 2a square. And in general I can tell an minus bn is going to be b minus a divided by 2 ka power n. Now that's a major step in this problem. Okay, now I can tell the segments a and bn have length which approaches 0 as the sequence goes to infinity. So you think in the limiting case when n tends to infinity, an minus bn जो है, if I see this sequence where it's going, so it's clearly limit n tends to infinity b minus c by 2 का power n. So this quantity is by the definition of limit will go to 0. इसका मतलब a and bn will go to a tending value or to a limiting value. It means if I take, let's say a1, which is an increasing sequence a2, a3, a4, a5, a6, and I start with some b1 which is decreasing sequence b1, b2, b3, b4, b5, c6, and so on. So at infinity, okay, they will try to go towards a certain value c. Okay, that is because of the continuity of the function. Okay. So we know like there is a real number c in this interval where the limit tries to convert to. So both of them will converge to the same limit, and let's say that convergent limit is c. So let c be their common limit, that is real number c is belonging to the interval, closed interval a to b. इसका मतलब what I am doing here is, तो ये जो आप गैप है मतलब यहाँ पे, ठीक है, तो f of k की करस्पॉन्डिंग कुछ आएगा, that I have to prove. But now I have sandwiched between these two interval of, you know, like an and bn के बीच में, an comma bn के बीच में I have sandwiched the output of the function. It means what I have done is, because now I have shown by this mechanism, like we have f of an and f of bn, and since k is between f of a and bn, so now I will show like there exists some input, okay, in the interval a to b such that will be achieved. So that again needs continuity idea. So यहाँ से what I can tell now, let's show now f of c equals k, so that if that limit value is c, so now my claim is the c is the point corresponding to which the output of the function was k. That is not very difficult to show, क्योंकि आप इसको show करने के लिए what I'm going to do is, for any in the natural number n, we know f of an by the way I have constructed is less than equal to k, less than equal to f of bn, right? ये तो यहीं से आ गया interval से, because you apply for f of 3, so you'll get f of 3 is less than equal to k and less than equal to f of b3. I repeat the process. So in general f of an will be between k and f of bn. So by this very construction, right? Now if I take limit, so limit tends to infinity, of course positive infinity I'm taking, f of an is less than equal to k, less than equal to limit a tends to infinity f of bn. Now since f is continuous at c, f is continuous at c, तो यहाँ से ये quantity क्या हो गया, this is f of c, because continuity is already mentioned in the problem. So it will be less than equal to k and less than equal to a tends to infinity, f being that sequence also towards c, तो ये भी f of c को approach कर गया. And now we have shown very beautifully, if k is a number between fc and fc, k has to be fc. So hence what we have shown is, there is a real number c in the interval, there exists c in the interval a to b such that f of c equal to k. I hope it is clear. Okay, so that was the beautiful proof behind a limit. In fact, most of the limit question, if you see the ipsa and delta definition also, so that is based on the sequence of numbers. Okay, so unfortunately for JEE preparation we don't do all this, but you see all the theorem is mentioned in the syllabus, but its essence and beautiful is often kept aside. Now just I want to remind you again, the hypothesis of continuity is essential in the theorem. Okay, and so you can't ignore this because you can apply the intermediate theorem for integer part function. Just suppose if I apply this for greatest integer function, so 0 to 1 may it will behave like this, 1 to 2 may greatest integer function will be this. So clearly, like if I take a number, let's say half, so corresponding to half there is no input. Okay, so there is no input in the system for which half will be obtained. This happened because we have violated the problem statement of IVT. So what IVT tells you is, if f is a continuous function defined, then we can talk about all these rituals, like for any number k belongs to that interval, there will be some input. But if k is discontinuous, we can't comment. Or in other words, the converse of this theorem is also not commentable. You can't comment on the converse. I hope those who are mathematics lovers, I enjoyed this. So clearly, disclaimer is this was not important seeing the objective pattern of the advanced examinations. But since the entire idea of calculus and the essence of calculus rest on this idea of IVT, hence I wanted to discuss it. Okay, if you want more problem solving for relevant JEE content, because for JEE Advanced and Mains, focus on mathematical problem solving should be more. Okay, so for that you can join my WhatsApp group as well, because we'll be starting course very soon. So you have last chance to join the group. Thank you.